Okay, so now let's explore a topic called resource expansion. Another thing we might need our API gateway to take care of is a requirement that we call resource expansion or link expansion. This is most easily seen in RESTful services that follow the HotOS principles, things like the team player example that we started the course with. If we have a mobile app that needs team and roster information all at once, like on one page, we should send this in a single call for efficiency. However, if we are following HotOS principles in our RESTful services, the team is one call which produces a link to the players which the client can follow if it chooses. Now, a mobile device, this is particularly expensive because it has to go over the mobile network twice. The API gateway is going to need to follow or expand this link so the real client doesn't have to. Effectively, the gateway will be undoing the HotOS. Now, there's nothing wrong with HotOS principles. They're fine. It's just that our client, our mobile client, can't really tolerate the inefficiency of making multiple trips. So this is exactly the type of thing that our gateway needs to take care of. One option for resource expansion is a library called Traversen. It is actually a JavaScript library for use with Node.js applications, but there is a small port of it contained within the Spring HotOS project. The name says it all. It is for traversing links automatically, making it so you don't need to do this as a matter of code. I'll show you how this works in the next slide, but first, let's cover the basics. If you want to use Traversen, you need to include these dependencies for Spring HotOS and JSON path. Remember, in Spring Boot apps, you don't need to specify a version if you want to take the default. After you add the dependencies, you'll need to create some resource classes. Now, the resource is actually a class defined in the Spring HotOS framework. Essentially, it is a wrapper for any domain object. And what it does is it contains a provision for links to other resources, so your domain objects don't have to model that. It also understands HAL structure, which happens to be the convention that Spring Data REST has chosen to follow by default. The example that you see here is actually pretty exotic. The resource for the player is actually wrapped in a resources class. And the resources class essentially is aware of things like arrays and collection usage. Now, I'll leave you to research this on your own if you like, in more detail, but for now just consider it a necessary wrapper for your objects to get Traversen to work with Spring Data REST services, or really anything that follows a HAL structure. Now, here is some code that actually utilizes the Traversen framework. First, you can see the setup. We provide the URL of the target service and the content type we expect. We don't have any integration with Ribbon here, no built-in integration. So if we wanted client-side load balancing, we would need to call Ribbon manually to obtain the URL. We could also supply a REST template to Traversen, where the REST template did the interaction with Ribbon, and handled the caching for that matter. The media type of HAL JSON is the only one supported at the time of this recording. Next, you can see we tell Traversen how to navigate the links on the document it retrieves. In effect, it is saying to use the first JSON path expression, that's the first string, to locate the link that we want to follow. Then call it, and then go seek out the second expression to find a subsequent link and follow that. In this case, we would have followed the first link to get a list of teams, then found the player's link of the first team in the collection. Now, this is utilizing JSON path syntax here. If you've never used JSON path, you can find resources on the web to explain it, but hopefully it's pretty easy to see that it is simply navigating through dot notation to find the links on the JSON document in question. And if you like, just back up a few minutes to see what the document looks like again. The resulting document is a list of player JSON objects, and these are unmarshaled into the player's resources, which basically can handle a collection of players. In essence, this is a collection of player resource objects, each of which has a player and perhaps some links to other resources. Now, if you call get content on either the player resources or the player resource, you get whatever it is holding. So if you call get content on player resource, you can see it is easy to loop through and print out the details of each player. There's 3 in this case. Traversen is made to make it reasonably easy to traverse link after link after link to explore and find what you are looking for. But it isn't really what we need for resource expansion, sorry to say. For us, we would have to make one call to get the team, probably using the REST template or Feign anyway, and then another call to get the players and manually attach them. So it's not exactly what we need. Also, it has a limited capability for JSON formats other than HAL. Now actually, it doesn't have a limited capability, it's just that we don't have any built-in resource objects for handling formats other than HAL. So the traversal works just fine with Traversen. But the final unmarshalling requires something that understands the exact structure of your final JSON document. And for us using Spring Data REST, it's HAL, and we have those resource classes provided by the Spring HotEOS project, so it's easy for us. But if you were calling something else, where the links were described in a different format, you would have to build your own classes with a compatible structure to handle that unmarshalling. And this isn't really the fault of Traversen. It's really up to however you have organized the JSON and your domain objects. There is also no support for XML, at least not as far as I've seen. So if you have XML-based services, you'll need to look at another solution. Now, it also hopefully goes without saying that SOAP-based web services are not supported here. Of course, if you are calling SOAP services, you will be dealing with other issues unrelated to link expansion anyway. So moving on from Traversen, let's look at another way of dealing with resource expansion. One way to deal with the issue is to have the resources expanded in the first place, have them pre-expanded. That is, to deliberately bypass the HotEOS concept of links in the original service. Now, if we can do this, the players will be included in the team resource, and there is no need for a separate expand step. Well, the good news here is if we are using Spring Data REST in our microservices, one technique we can use is called a projection. Now, a projection is a feature of Spring Data REST which causes links to be inlined or pre-expanded. We can set this up to be permanent or optional. If it's optional, we can trigger it based on an incoming HTTP parameter. I'll show you that in a second. If it is optional, the nice thing is that we have a REST service that still embraces the HotEOS principles while allowing us a quick way to bypass them when we really need a more efficient scenario. To use the projection feature of Spring Data REST is actually pretty easy. First, you define an interface in which you describe exactly the properties of the domain object or objects that you wish to expose over REST. You can see here I have an inline players projection, and I have included the getPlayers method. Now this is actually describing the team with the players inline. That's where the name comes from. The name can be anything you want. It's just there's a method to it here. Now this is going to ensure that the players are inline. You add this @projection annotation to identify it to the framework, and then you specify which parent object this projection applies to. This is the team that it applies to. So this is all fairly straightforward. Now, if you want the framework to always return the data in this form, you would need to do something that I don't have here. You would need to describe this interface to the repository using the @repository REST service. But if not, like we're going to do here, all you need to do is provide the name of the projection as an optional parameter on a GET request. And that's it. From this point on, if you supply the projection equals inline players parameter, the framework will render the players as part of the team. And when you leave this parameter out, you will get default HotEOS behavior of link generation. And here is the result. You can see on the left, if I just ask for a team resource, I get the links to the associated resources, as one would expect, and a client would need to follow or expand those links. But on the right, you can see I have provided the projection request parameter. The framework then inlines the players just as we like. If you take a close look at either of these responses, you can see that the self link that is generated provides a hint that the projection is available. However, it doesn't tell you what value can be used here, so it's a little bit of a shortcoming in my opinion. I think that the projection capability built into Spring Data REST is excellent, but there are some drawbacks in a microservice application. First, it is only available when using Spring Data REST, and of course, one of the principles in microservices is that the various services could be written in various languages and frameworks, so we might not always have this as an option. Secondly, the projections are limited to the same microservice. Now, our example works here because the same service is serving up both teams and players. But if this was a real-world application used by something like a professional sports league, we might find that the players and teams are sophisticated enough, they're complex domains on their own, and therefore they would need to be implemented as separate services anyway, so we're kind of back to square one. But aside from those items, it is a pretty good solution that you should use when you can. And if you'd like to learn more about Spring Data REST projections, I'll refer you to the Spring Data REST reference guide at this point, since any further detail is a bit tangential to our objectives.